Hello everyone, I'm Sorish Mitra from Sri Venkateshwara College of Engineering. I'm a second year student pursuing BE in Science and my branch is Computer Science and Engineering. Today I'll be giving a presentation on the topic probability theory. Probability theory is a fundamental branch of mathematics that deals with analysis of random events. It provides a framework for understanding uncertainty and making predictions based on the data. Basics of probability. The basics of probability are a fundamental concept. Probability basics involve understanding the likelihood of an event usually occurring represented as number between 0 and 1. Probability models. Basic probability includes the study of various models such as discrete and continuous probability distributions. Probabilistic thinking. Developing the ability to think more probabilistically is crucial for making informed decisions and analyze data. What is Poisson distribution? Poisson distribution definition and characteristics. The Poisson distribution is used to model the number of events that occur in a fixed interval of time or space. Probability function. It is the characterized by the parameters phi wavelength representing the average of occurrence in the interval. Real world applications. It is commonly used in areas such as telecommunication, biology, and quality control. Binomial distribution. Definition and characteristics. The binomial distribution describes the number of successes in a fixed number of independent trials. Probability function. It is characterized by the parameter n number of trials and p probability of success on each trial. What are the practical applications of binomial distribution? It is widely used in quality control, market research, and hypothesis testing. Exponential distribution. Definition and applications. The characteristic feature exponential distribution models the time between event in a Poisson process with constant rate of occurrence. The key application it is applies in reliability engineering, queuing theory, and survival analysis. Introduction of joint probability distribution. Understanding joint probability distribution is a fundamental in probability theory and statistics. It involves the likelihood of two discrete random variables occurring in simultaneous and provides valuable insights for various applications. Definition of joint probability distribution. Simultaneous events. The joint probability distribution defines the likelihood of two or more events happening together in a probability space, providing a comprehensive view of their combined outcomes. Probability mass function. It describes the probability of different combinations of outcome for the given random variable, enabling the evaluation of the joint behavior. Independence and dependence. It allows the assessment of independence or dependence between random variables influencing decision making and risk analysis. Calculation of joint probability. Multiplication rule. The multiplication of the probabilities of individual event provides the joint probability of the intersection, offering a systematic approach to compute joint probabilities. Contingency tables. Organizing data into contingency tables aids in visualizing and calculating joint probabilities for various combination of discrete random variables. Conditional probabilities. Conditional on Conditioning on the specific events enables the determination of joint probabilities under various scenarios, enhancing predictive analysis. Expectation of joint probability distribution. Mean of combined outcomes. The expectations represents the weighted average of the outcomes of two or more random variables based on the joint probability distribution. It provides a measure of central tendency for the combined outcomes, aiding in the decision making and risk assessment. Calculating and the expected values. The integration or summation over all provided possible outcomes weighted by the probabilities yields the expectations of joint probability distribution. This concept is essential in understanding the average behavior of two multiple random variables. Covariance of two random variables. Measure of relationship. Covariance indicates the extent to which two random variables change together, providing insights to into the direction and strength of the relationship. Positive and negative covariance. So, positive covariance signifies a direct relationship, while negative covariance decides the indication of an inverse relationship between the random variables. Calculation and interpretation. The calculation of interpretation or interpretation of covariance plays a key role in understanding the joint behavior and interaction between random variables. Calculation of variance for two discrete random variables. Covariance. The formula involves the multiplication of differences between the values of each variable and their respected expected values weighted by the probabilities. Interpreting covariance value. A covariance value is close to a zero indicates weak or no linear relation, while positive or negative value signifies a significant linear relationship between the variables. Application in risk management. Covariance is utilized to assess the combined risk associated with two variables, guiding portfolio diversification and assessed all allocations decision. Interpretation of covariance, direction and magnitude. Covariance offers insights into direction, whether positive or negative, and the magnitude of association between two random variables, aiding in decision making and analysis. Matrix representation. Utilization. A matrix representation helps visualize and analyze the joint variability and the relation between multiple pairs of random variables simultaneously. Correlation between two random variables, strength and direction. Correlation between measures the both strength and direction of the linear relationship between two random variables ranging from -1 to 1. Interpretation. A correlation value close to 1 indicates a strong positive relation, while close to -1 signifies a strong negative relation. Used in decision making. Correlation assisting in understanding the interdependence between variables impacting financial analysis, research, and predictive modeling. Calculation of correlation coefficient for two discrete random variables. Formula application. The correlation coefficient is calculated by standardizing covariance and provides a normalized measure of linear relation between discrete random variables. Strength and significance. The coefficient magnitude reflects the strength of the relation, while its sign dictates the direction, enabling robust comparison between across different data sets. 3. Limitations and considerations. Understanding the limitations of correlation coefficient is crucial, especially in presence of outliner on non-outliner relationship, ensuring accurate interpretation and analysis. Interpretation of correlation coefficient. Statistical significance. The correlation coefficient aids in determining the statistical significance of relationship between the discrete random variables, crucial for hypothesis testing and research conclusion. It enables the assessment of degree to which changes in one predict value, another guiding decision making forecasting. Real world application, from analysis financial analysis to scientific research, interpreting correlation coefficient influence the strategic plan, risk management, and the development of predictive models. Understanding correlation helps in identifying influential variables and refining analytic approach for impactful outcomes. Conclusion. Probability theory provides a foundation for understanding uncertainty, making informed decision, and analyzing a wide range of real-world phenomena. The various distribution and concepts within probability are crucial tools for data analyzing and modeling in numerous fields. Thank you, everyone. Please do like, share, and subscribe to this video.